Hi, I'm Arnie, and this week's aim during our lab session was to conduct an experiment to determine the acceleration due to gravity when an object falls freely near the Earth's surface. Its motion is described by the equations of constant acceleration, also known as the kinematic equations. During the experiment, as shown in the video and the diagram I created using chemics, a retort stand is placed with a hair trigger release mechanism to ensure the marble gains no additional force during release, ensuring free fall from rest while ensuring the marble will be released at a known consistent height. While conducting the experiment, we set up a camera where we placed a meter ruler vertically and used it in conjunction with a frame-by-frame software to determine the ball's position at different times, with the ruler providing a reference scale in the video. The experiment was conducted on a flat surface to prevent warping during filming. By measuring the full-time end height, we calculate the value of acceleration due to gravity and compare it with the accepted value of about 9.8 meters per second squared. The experiment is based on the physics of freefall under constant acceleration, using the concept that when the ball is released from rest, its displacement is related to the equation S equals 1 half at squared. This equation tells us that the distance fallen is proportional to the square of the time, meaning that if we measure the distance and time accurately, we can calculate the acceleration due to gravity to perform the experiment. We dropped a ball from a measured height of 42.5 centimeters or 0.425 meters, and the fall time was recorded using frame counting software to determine the exact moment the marble hit the floor. This, along with the hair trigger release mechanism, mitigated one potential challenge, as the human reaction time can induce error. To minimize inaccuracy, we employed multiple techniques, one of which is in ball selection for the drop test, where we were given a choice of styrofoam, rubber, and marble balls. The importance of selecting the correct ball comes from the fact that the forces that interact with the ball during free fall are the gravitational force and drag, i.e., air resistance. With the gravitational force will increase as mass increases due to the formula F equals mg. The air resistance is a drag force that acts opposite to the direction of motion. As the ball falls and its speed increases, the drag force increases, slightly reducing the acceleration. And due to the drag force being calculated by surface area, the mass of the ball does not matter. Therefore, in this experiment, a marble was used instead of a styrofoam ball because it had much greater mass. This reduces the relative effect of air resistance, allowing the ball to behave more closely to ideal freefall. Using a light-up object such as a styrofoam ball would increase the effect of drag and lead to less accurate measurements of gravitational acceleration. From the experiment, the marble fell on average 0.39 meters in about 0.3 seconds. Using the free fall equation, this produced an estimated gravitational acceleration of roughly 8.7 meters per second squared. While slightly lower than the accepted value of 9.81 meters per second squared, the result is reasonably close, and the difference can be attributed to measurement uncertainty and small experimental errors. In conclusion, this experiment demonstrated that the motion of a free-falling object follows the equations of constant acceleration. By analyzing the fall time of a marble dropped from a known height, we were able to estimate the acceleration due to gravity. Our calculated value was reasonably close to the accepted value of 9.81 meters per second squared, with small differences likely caused by measurement inaccuracy and minor air resistance.